The last class we were doing convergence. Radians into degrees. Now the fourth one, 1/4 radians we have to convert into degrees. So you know that whenever we convert this into degrees, we always multiply it by what? 180 upon 5. So first cancel if anything is getting cancelled and simplify this and see how much you are getting. Now previous problems, if you had seen, there should be a pi there which is to cancel. And in this case, this pi will not cancel. So you just normally cancel what is getting cancelled. So 4 4s are 16, 4 5s are 20. So you will get 45 upon pi as your answer. But you know that degrees we cannot keep like this. It has to be a like either in minutes or whatever like that, a pure number, no decimal, nothing. So pi value is how much? 22 upon 7. We can put 22 by 7. So fraction upon this, so this will become ulta. 7 upon 22 you will get. Now multiply this and write how much I get. So till this step you should get. Now you know that you cannot leave this into a fraction. You have to convert into mixed fraction. Quotient, remainder upon divisor form. So in the rough work, do the actual division. 315 divided by 22. And see how much you're getting. Check if you're getting this. Okay, so the remainder is here. So now 315 upon 22 can be converted into mixed fraction as quotient, remainder upon divisor. So this is your divisor, quotient, and the remainder. So 14, 7 upon 22. Now what you have to do next to convert into minutes, multiply it by 60. So we have to multiply whatever number we get into 60. Only this calculation is to do, not with this. And don't cancel this and this number and all. If here you cannot cancel. This is of this part. No? 11 and just 30, no? Already the degree part we got, like 14 degrees we have got. Now into 60 minutes. So what you are getting? 14, again 210 upon 11. Again, minutes is remaining in terms of fractions now. So what is the thing now? Again, go for another division. 2 times. Second time. So this is a minute now, no? So convert this. Again, convert into a mixed fraction. So 11 ones are 11. So 10 will remain 100. 11 nines are 99. So I will write this now. This is degrees. So 14 degree. Then again quotient remainder upon divisor. Quotient remainder upon divisor. So you got the minute. So 14 degree, 19 minutes. And last what you need? Seconds. So multiply again by 60. So 2 times your major division, okay? Quotient remainder upon divisor. Now what is the problem? Yeah. So you'll get 14 degree, 19 minutes. Again, 60 upon 11 you're getting as a fraction. So last time division. Whatever division you get, no, now this will be your final division. So this one you do in terms of decimal points because we don't go again ahead of seconds. There is nothing what we have learned. So this is your final division. So that you can write in terms of decimal points. So 11 5s are 55. Now point. Now don't write mixed fraction again. Huh? Done. Only 2 times. How you'll know you have to stop because only 2 times maximum we can multiply by 60. Third time we cannot multiply by 60. So approximate number you can guess. So you are getting 5.4, no? So which can be, you know that you cannot write decimal point. So 5.4 means you'll have to just convert to the other side. You know, rounding off. Smaller than 5, you know that you have to take it back to your. So answer is approximately 14 degree, 19 minutes, 5 seconds. So like this. Now do the fifth one. Exactly same way, try the fifth one. 6 radians. So maximum 2 times we can multiply it by 60. One is for minutes, one is for seconds. And the third time division, whatever you do, has to be converted or rounded off to the nearest point. 6 radians. 6. Only 6 C. Okay. Convert. So first multiply it with 180 upon pi. Then nothing will cancel. So directly put the value of pi as 22 by 7. Now cancel if something is getting cancelled. Even if you have multiplied first and written 540, that is also okay. Again, you can cancel. I'm cancelling it. 2 3s are 6, 11s are. Anything else is getting cancelled? No. So multiply all these numbers. If you're getting on something else, different you're getting. 3780. Higher, here again. 7, I multiplied it with 3. Okay. Now divide. Go for long division and write quotient remainder upon divisor form. Getting like this. This is the degree part. We got the degree. Into 60. You know that this will not cancel anyways. The next step will be 343 into 2 for another degree. So 120 upon 11. Now this division, you know, you have to round off to the closest number. 10.9. So 10.9 will be rounded off to 11. Seconds. 11, yeah. Okay. And same way to the sixth one. Minus you keep out, huh? Minus no taking inside the calculation part. Minus you have to just keep on writing out. That's the last minus. So again, same way, multiply it with 180 upon pi. Then pi you put it as 22 by 7. Make it ulta as 7 by 22. Or directly also you can write 7 by 22. Then do the calculation. So no formula, nothing to by heart. Directly, you know that 2 times you have to divide. Only remember you have to multiply by 62 times in case required. Directly, if you don't get a fraction, then you can leave the answer. But if you get a fraction, 2 times you'll have to go for division. So you'll get 114 degree remainder upon divide. Now multiply it by 60. Now go for second division. Any difficulty? Something? This is correct. By 1 3 is 33. पण नाही ते cover असतं. ते ऑफिसर. Some other number, some mistake, yeah? You're not getting difference. Minus some, that minus 7. The idea of that. So 480 upon 11. Now you know that already I multiplied 62 times. The third time division has to be rounded off to the closest number. It will be 44. Getting this? Check. Huh? Then odd and even is there, no? With odd number. No. Yeah, then you have to check. You usually in maths, we can directly round off it to 44 only, 5 or above. Chemistry, I think there is something, no odd and even. You can directly 44. Okay. So this is given like how any radians given. This is how we convert into degree. Clear? Degrees into radians is good because we can leave the answer in terms of fractions only. You don't have to do all. Third question. These are like kind of word problems based on, remember last class we had seen for radians also. One whole circle is one revolution, which is 360 degrees. One whole circle is same as the circumference also. And like we had taken some radius, arc length, yes, L, and this is the theta. So what is the formula? No, where theta I gave? Let's check. Yeah, that's what I was. Check. No, L upon. Or you can write it as L equals to R. Okay. 180 is when half circle. Full circle is 360. So if this is one, your theta will be 1 radian like that. So this angle, right, always this is in terms of radians or not degrees. So whenever we use this formula, this will always be, angle will be in terms of radians, not degrees. So if they ask in terms of degrees, then we'll have to convert it into degrees. Whatever answer, so we'll solve problems anyways, we'll understand that. The first one, question number 3, a wheel makes 360 revolutions in 1 minute. So in 1 minute, okay. So they have given in 1 minute, it is making 360 revolutions. How many radians does it turn in 1 second? In 1 second, how many radians? So I can write it this side. So we'll do the solution part now. This is the question. This is given and this is asked. So first, the solution part. In 1 minute, it is going 360 times. Okay. So you can check 360 revolutions. How many it is taking? Either ways you can write. Okay. So we'll see how much time it is taking for one particular revolution. So one revolution. Okay, how many turns it is taking? Again, it is coming as how much? 361 upon 360. No, but this is asked 1 second. This is asked in terms of seconds, no? Revolutions. Okay. Wait. I'll give you a easier way to frame. I'll give you this way otherwise, wait. Because it will come as 1 upon 360 and then you'll have to again do division. Wait. I'll give you in a way. Okay, so 1 minute. So one will calculate in terms of degrees as well. One revolution, one whole circle will be how much in terms, because this is asked in terms of radians. Okay, so we'll check then. So one revolution, how many degrees directly? 360. Okay, so O1 equals to circumference. So 360, okay, will be equals to how much? 2 pi radians, no? So we'll have to see. Like this one. 360 degree. So 360 degree it is given. I wrote wrong, I think. Sorry. That's why I'm thinking. This degree is not there. Huh? This degree was not there. In the question, it is not there. By mistake, I wrote there. That's why I'm thinking what I did. Huh. Okay. Now it's clear. One revolution is 360 degree. So this I was getting confused. Okay. So 360 revolutions. How many degrees it will have? Okay. But the answer is asked in terms of radians, correct? How many radians? So 360 is same as how much? You can also write it as what? We had learned how much it was full 360 in terms of radians. A full circle, 2 pi, no? 360 means how much? 2 pi. So you can also write it as 2 pi. So you can put it as x. So instead of 360, I'll write it 2 pi radians. So while calculating, you write like this, 1 upon 360. If the answer was asked in terms of degree, directly you have to divide 360 upon x. Here what you do is 1 by 360, 2 pi upon x. Instead of 360, I'm using 2 pi radians. Okay. So calculate the value of x, how much you're getting. Okay, no? So okay. Something is going on. And pi. So many radians. One revolution. Take the question again 1 second. Huh? A wheel makes 360 revolutions in 1 minute. Later, we'll have to convert in terms of seconds. And I'll just get first one level. Radius is not given, no? How many does it through? One full revolution will be 2 pi radians. In terms of x. Similar one is done for you all, no? Wait, I'll just check the question. Correct. Directly, otherwise the question is fine. Wait. I'll try first. Wait 1 second. Huh? So 1 minute, we want in terms of seconds. Okay, wait 1 second. I think I will get this. Revolution. So 60 seconds will be how many will be asked, suppose. So 1 upon 60, 360 upon x. So x will be 360 upon 60. Now this is getting multiplied. 1 second. 1 second will be how many? So 60 upon 1 will be 360 upon x. So x will be 360 upon 60. X is 60. 6. So 6 revolutions. But we want in terms of radians, suppose. So this is x, no? So 1 second is equal to 6 revolutions. Okay. So we want in terms of radians, no? So 1 revolution will be 2 pi radians. So 6 revolutions will be how many? So 1 by 6 into 2 pi by x. So x will be 2 to 612 pi, no? Yeah, correct. So 12 pi radians will be answer. Just check if it is correct. Okay. So I'll explain to you. Okay. Now 1 minute is given as 360 revolutions. So how many radians? Now this is the problem because this is revolution. This is asked in terms of radians. This is a little bit confusing. So what happens is first we'll have to check only in terms of revolutions because we'll have to do this in 2 parts. So first what we'll do is 1 minute we know is 360 revolutions. So this part is given. But the answer asked is in terms of seconds. So we'll have to write first whatever the main part in terms of seconds. So if this was also in minutes, no problem. Directly we could check. But since this is in seconds, so 1 minute first we'll have to write in terms of seconds. So just instead of minute, I've written 60 seconds is equals to 360 revolutions. In 1 second, how many revolutions will it go to? So then you know that how to solve. This upon this equals to 360 upon x. So we need to find the value of x. So first 60x will get it as 360 and then 60 will come down or directly you can exchange cross multiply. So here we'll get it as x as 6 revolutions. So x means what? Therefore, this is in 1 second. In 1 second, we are getting 6 revolutions. But the problem is asked in terms of again radians. So you know that one revolution is 2 pi radians. So we want how many radians it will go for 6 revolutions. So 6 revolutions means 6 rounds it is going to take. So x of them. So directly also you could write 12 also if you don't want to do this calculation, because one circle is 2 pi. 2 circle will be 4 pi. 6 circle will be 12 pi. So then it will be 12 pi. Now in my head I was thinking that 360 on the every time. That's okay. That's fine. The fourth one. Third one, any difficulty? Okay, fourth one, find a degree measure of the angle subtended at the center of a circle with radius as 100 centimeter, arc length of 22 centimeter. Angle we have to calculate. Arc length is given, radius is given, angle we have to calculate. But angle is again asked in terms of degrees. And this angle, you know what, is always in terms of radians. So first we'll calculate the radians, then you know how to convert into degrees, radians to degrees. So which is that formula? Use that. Theta is L upon R. Just directly. So check. Both are centimeters. So you can take directly now. If units were different, you have to first convert into the same unit. So right, 22 upon 100 you do. If it is asked in terms of radians, then leave the answer as it is. In exams, if they have not mentioned in degrees, you can directly write radians and keep. Now, but in this particular question, they have asked specifically in terms of degrees. So you are getting 11 upon 50 radians. How you convert in terms of degrees? Multiply it by 180 upon pi. Now calculate the answer. You did pi by 180. Is it? No. Okay. No, but pi, how it came up? We are converting from radians to degrees. Number on top, pi will be in the denominator. So multiply it with 180 upon pi, and now that long division method what we were doing. Do. Benjamin, do. Understood this, no? This what we got is in terms of radians. Now convert in terms of degrees. How we convert? Multiply it with 180 upon pi. And then start solving. Pi. So pi is 22 by 7. So it will become ulta and then 7 by 20. So I'm directly writing it as 7 by 20. Again 9 here, 11. But 11 and 11 will cancel. 63 upon 5 you are getting. So divide 63 with 5. 5. One question. By 0. Then into 60. Directly, I think it's getting cancelled, no? Just check. 5 ones are 5. 36 straight away. Here no fraction, so no more division. So we have to stop here. One more calculation, maybe cancellation you have missed out. 22. Yeah. Well, 11 and 11, no? 11 ones are then 11. So this is in terms of degree. If radians was asked, you have to stop here. Not, you have to do this. Understood? Okay. Then the next one. This should be arc length. Textbook here. Question is third one. Okay. 40 centimeter length of the curve. Okay. So there is a circle with diameter 40 centimeters. So radius will be how much straight away? You know, that is 20 centimeter, half of the diameter. So even if diameter is given, you know the radius. Now you know this is also 20. What they are trying to tell is this is 20. They are saying radius is 20. So you know this side of chord is given. Chord means this one, not the arc length. Okay. This chord is given as 20. All are 20 centimeters. And arc length is asked of the minor chord. This one. Both words they have used chord only actually. Arc length they should have made. Here it's minor arc of the chord. This is missed out there. Find length of minor arc of the chord. Word arc is missed out over there in the question, so just add over there. This is that arc. Minor chord I have written no by mistake. Chord means this, but minor arc of that particular chord, not the bigger one. This length is asked. So use the word arc over there the side. So even if one word is missing, the entire question changes. So minor arc. So L is asked. Now the problem is what? What is the formula? Theta is L upon R. Now this to find only radius you know. So in order to find the length, you need the radius also, you need the angle also. Angle is not given, but what you have noticed, it's an equilateral triangle. Okay, so you can name as AOB, whatever. So first you can write triangle AOB is an equilateral triangle. Therefore, you know that all angles will be 60 degree. Equilateral triangle, angle will be equal. 60, 60, 60. So we got degree. Now what is the problem? When we go to write the formula, this has to be what? Radians. So we will need answer in terms of radians to substitute. So this is degree. So convert it in terms of radians. So 60. So this will be in terms of radians. Calculate this. And now whatever angle you get, that you have to substitute over. So that formula, whichever you use, remember that angle is always in terms of radians. Suppose if the question, this is given in terms of degree, first, or if you directly know how much is 60 degree, last class I told you how to remove pi by 3. So this is not required then. Straight away you can write pi by 3. If you directly know the answer, you can write it as pi by 3. If you don't know, then convert. Now write the formula and substitute. Now we wanted L, no? So this will go up here. R is given to us as 20 and theta is pi by 3. So pi, if you want, you can write it as 3.14 also. And then multiply. Pi by 3, no? 22 by 7 you took. So this you can write it as 20. Sideways I've written there. Pi, you'll get like this. Then this you can write in terms of decimal points or check if in the college if they are keeping in terms of pi centimeters, you can leave it as it is. Some of them may write just pi centimeters and keep, some of them may convert. This you can write directly. No doing that, huh? Like into 60 and all. This is length. So directly. Nine done, something 20.9. This also will be in terms of centimeter. Don't forget to write the unit. Huh? This is the arc length. Now read the next one. Number 6. The minute hand of the watch is 1.5 centimeter long. How far the tip moves in 40 minutes? You can consider it as the radius. Okay. So first we'll have to check how much angle it is covering in 40 minutes. Then we'll have to check the arc length. So it is basically like maybe it has covered around 40 minutes. Much arc length it is. But first we'll have to know how much theta is also there. So you know that watch, no? So it is what? Minute hand of the watch. So one whole minute will cover how much? 360. But we'll need it in terms of what? Radians also, no? Answer. Because angle will need it. Or if you are okay with first three degrees, and then again you can convert in terms of radians. Or directly you can write 1 minute is how much? 2 pi radian. So 40 minutes, how many radians it will take? So calculate. This will be our angle. Or 360 also you can do. And then how many degrees it is getting in 40 minutes. Then write the angle formula and substitute theta. What answer you are getting? But big answer. 80 pi you are getting. 1 minute. Wait, 360. Hours it will be, no? One full. R will be 360 degree radians, no? Full circle of the clock. Because 40 minutes will be like so many times it will go. 40 minutes. Wait, I'm just thinking. No. 1 hour it should be. The smaller hand, no? Minute hand and the hour hand. So 1 hour to complete, the whole thing will go 360. Check, I'll check, but I think so. This should be this one. If you all have done, then I'll check. Should be 1 hour. So this should be, this is correct, but 60 minutes should be 2 pi. Because one whole 1 hour, no? So 140 minutes. I'll confirm the answer. Let's see. I think according to me it should be this. 60 minutes should be 2 pi radians. 40 minutes should be how many? So 60 upon 40. Because at least clock we've considered that way. One whole 1 hour will be 2 pi radians. Because 60 minutes will be equals to 2 pi radian. So 6x will be 8 pi. You all have done this in the college, then you could check the answer. Should be this. This should be the answer, I think. One. Otherwise, I'll check it on the app. I'll check. This will be 0.5. 0.5 into 4. Directly you can multiply it with 3.14. 6.28 centimeter. Well, I'll check and tell you next time. But I think 100% it has to be this only. 60 minutes should be equals to 2 pi. 40 minutes should be x-ray. Remember this to take. 1 hour is always 2 pi radians, not with the minute hand. The hour hand we consider. Huh? Convert what? This is radians only, no? Directly I took in terms of radians. No. Here we have to substitute. This has to be in terms of radians. Understood? If you are taking, otherwise do this. 60 minutes, 360 degree. 40 minutes is equals to how many degrees? So this answer will get in terms of degrees. Then you'll have to multiply it with pi by 180 and then convert. Well, it should be this. This is directly in terms of radians, so you can substitute. Take 1 RS 2 pi radians while solving the problem. Still we'll see, like, at least all this year it was like this. You see how it. Okay. In a circle, arc of same length subtend angle 60. So there is one circle which is having 60 degree. Length is the same. And one circle having 75 degree. Again, length is the same. Find the ratio of their radius. So this is one circle. Circle 2. R1 is same. R1 and R2 is different. Here theta is 60 degree. Here theta. L1 is same as L2 equals to L. There are two circles. One circle of 60 degree, one circle of having angle 75 degree, but their arc length is same, they are saying. Now let us find the ratio. Ratio means like this. R1 upon R2 is how much? Again, now what is happening? The angle given is in terms of degrees. So first find theta 1 in terms of pi. Both the angles you find in terms of radian. Degree you convert in terms of radian. Because we will need that formula. You know that arc length, radius, and angle wherever it is given, your angle has to always be in terms of radius. So now what they have given is in terms of degrees. So convert them in terms of radians. So this is straight away pi by 3. Pi by 12. What happened? Directly they show you to. No. You are told like that, direct degrees you can substitute in the formula. Okay. I thought directly fifth step. Good. So the formula is what for circle 1 will write. Circle 1. So we'll just put 1 and 1. L equals to R theta is the formula we know. But since there are two circles, we'll name the first circle as 1, 1, 1 everywhere. But you know again L1 is same as L, so you can put L over there. R1 we don't know. And theta is how much? Pi by 3. So mark this as equation 1. So this is for circle 1. Now circle 2, again write the same formula. But this time we put 2. Again L2 is also same as L. R2 we don't know. Theta 2 is 5 pi by 12. Now ratio means you know that equation 1 divided by equation 1 upon. So this side it will be L upon L only. Anyways. This will cancel. So R1 upon R2, you can just keep them at the side. So pi by 3 into this will become 1. So we'll get it as. Now take this ulta. This will go up here when you need R1 upon R2. So 5 will go up here, 4 will come. Getting the same answer, you can do it various ways also. However you want to divide, or first you could take them on the other side, whichever. Answer should be 5 upon 4. This is how we calculate the ratio. If suppose R was given as same, then R1 equals to R2 you have to take as R, and length you have to substitute. Suppose. Okay. Then 8-1. Find the angle in radians. Timer. Okay, last one. Find the angle in radians through which pendulum swings if its length is 75 centimeter and the tip describes the arc of the length of 10 centimeter. You know that pendulum you all have done already experiment in physics? No, not yet. So you all will come across that. At least the old watches you all have watched, seen, no? The pendulum. So it swings to and fro, like it goes back and comes back. So it is in the form of arc like. So this is the pendulum. So it will move like this, it will move like this. And it will keep moving. So this will be like an angle. Angle is asked. This one's length is 75. So you know that 75, everywhere it will remain as 75. Not degree. Every time I write degree in centimeter. And arc length of 10. Now calculate the angle. What this is to be considered? Tell me. This is L. Arc length of 10. Clearly given. What about this fellow? Who is this? Radius. Now, anyways, here what has been told? Find the angle in radians only. So whatever answer you get will be a final answer. You don't have to convert in terms of degrees. Or theta is L by R. Simple enough. So theta will be If they had asked in terms of degrees, then you have to multiply it by 180 upon pi and do that long division. Okay, so these are your topics. Only in some college like Rosaries and all, they do the word problem. Some colleges they might skip also this. Directly they go for trigonometry. Okay, so we'll stop here. So next class from onwards, like the main will come. Okay, the main topics. Whatever will like formula, everything will come up over there. Now this you all see, only if it is done in your college, you all can learn. Otherwise, you all can skip the word problems.